Today's lesson is called 4 Interesting Transformations of Functions, Day 4. We've already discussed the summary chart that you see here, but let me quickly go over that with you. When you look at the chart is organized by vertical on the left-hand side and horizontal on the right-hand side. All vertical changes are when K is on the outside. All horizontal changes are when K is on the inside. On the left-hand side, it's broken into rows based on whether you're translating, which remember is a slide or a shift. That means you're going to be adding or subtracting, okay, a number on the outside or a number on the inside. And then the bottom row is your scaling, which means you're going to be multiplying by a positive or a negative on the outside or the inside. We went over all the different ways that this affects the equations and the graphs. So if you add on the outside, you translate up. If you subtract or add a negative on the outside, you translate down. When it moves to the inside, if it's a positive number inside, you actually move left. If it's a negative number inside, you actually move right. So remember what we said, it's kind of the opposite of what your gut tells you to do for horizontal. When you're looking at multiplying for scaling, if you multiply by a number bigger than 1 on the outside, it's a vertical stretch, which means it's going to get taller and skinnier. If you multiply by a number between 0 and 1, like 1/2, it's a vertical shrink, so it's going to get shorter. If you also multiply by those types of numbers, but also negative, remember that it also includes a reflection over the x-axis because the number's on the outside. When you look at horizontal inside, if it's bigger than 1, it's a horizontal stretch, which means it's wider. If it's between 0 and 1, it's a horizontal shrink, which means it gets skinnier. If you are then going to multiply by a negative as well, remember that it makes a reflection. And because it's on the inside, rather than reflecting over the x-axis, we reflect over the y-axis. So now we'll look at some examples. Example 1, the graph y equals f of x of a piecewise function f is shown below. The domain of f is -5 is less than or equal to x is less than or equal to 5. And the range is -1 is less than or equal to y is less than or equal to 3. A wants us to mark and identify 4 strategic points helpful in sketching the graph of y equals f of x. So our key points are going to be right here at the end at -5, -1. Right here is another place where you can tell that that line segment ends. So -1, 1. The next piece ends here at 3, 1. And lastly, at the edge here, we have 5, 3. Those key points will help us sketch the graph. Now moving on to part B, they want us to sketch the graph of y equals 2f of x. So we're going to multiply by 2 on the outside and state the domain and range of the transformed function. How can you use part A to help sketch the graph of y equals 2 times f of x? So the way we're going to use part A is we're going to use those points to help us create the transformation. So when I see y equals 2 times f of x, I see that it's a number bigger than 1 and it's on the outside. So that means that it's a vertical stretch with your scale factor as k equals 2. Now we'll use the points to help us. If I write down the coordinates from the previous page, we had -5, -1, -1, 1, 3, 1, and 5, 3. We are going to make the changes we need to create our new coordinates. So if I'm going to do a vertical stretch with a scale factor of k, that's going to affect the output, which remember output is y. So I'm going to keep the same x value, but I'm going to multiply my y value by 2. So I would get -2. For -1, 1, again, I would keep my same x value. The input was not affected. If I'm multiplying on the outside, it's the output or y that's affected. So 1 times 2 would be 2. So my coordinate 3, 1 would change into 3, 2, because 1 times 2 is 2. And my last coordinate would change into 5, 6, because I'm multiplying my y coordinate only by 2. So now we can go to the graph and plot those critical points, -5, -2, -1, 2, 3, 2, and 5, 6. And then we will connect them in the same way they were originally connected. And you can see what we've done is we've taken and vertically stretched it. So if I grabbed this on the top and the bottom and I pulled in both directions, we vertically stretched this graph. Lastly, they want us to write down the domain and the range. So our domain now has not been affected. I'm still going from -5 up to +5. What is affected is the range. So let's put a star by that one, because since we were multiplying on the outside, it was our y values or our output that was affected. So our range actually changes. My lowest y value is here at -2, and my highest is at 6. So we have -2 is less than or equal to y is less than or equal to 6. In part C, it says sketch the graph of y equals f of x minus 3 and state the domain and range of the transform function. How can you use part A to help sketch the graph of y equals f of x minus 3? So again, the way we're going to use part A is to use the critical points. So I will write those down again, -5, -1, -1, 1, 3, 1, and 5, 3. We'll create arrows here so that we can make the changes. Now let's think about what we're doing here. Because we are subtracting by a 3 on the outside, that means we're going to translate down. Now at any point, you can go back up and look at your chart to see that. You can follow the chart. So if I saw -3 on the outside, I would go to my translate section. I would do the part where k is less than 0, and that would remind me that I'm translating down. So we're going to translate down 3 units because of the -3 on the outside. So again, because it's on the outside, it's affecting the y's, not the x's. So we're going to have to subtract 3 from the y values. So over here again, my x's are not going to change. So I'm going to preload all of those actually. And now I know I need to subtract 3 from all my y values. So -1 minus 3 would be -4. 1 minus 3 would be -2. 1 minus 3 would be -2. And 3 minus 3 would be 0. So we can plot these points now. -5, -4, -1, -2, 3, -2, and 5, 0. So this time we have taken the original and we've slid it down. Now let's go back and actually label all these. So this should have been y equals f of x minus 3. We'll go back up here. This should be y equals 2 times f of x. Okay, so make sure you have your labels. At this time, if your teacher has assigned you a practice assignment, you should go complete that now. If they have not, you're going to stop the video, complete the practice, and then resume the video when you're ready to go over your answers. You can also resume the video if you do your separate practice activity and need any verbal explanations of the answers. So now that you've completed the practice, let's go over the answers. Your parent function for this first 5 questions is let f of x equal x squared. So I'll mark that for you right here. X can be any real number. Your job is to write a formula for the function whose graph is the transformation of the graph of f given the instructions below. So the chart would have been really helpful to use here. If you're going to translate right 5 units, since I'm going to the right, I know it needs to be on the inside. And remember that the inside works the opposite of natural movement. So I'm actually going to subtract 5 on the inside. Now for all of these, you'll notice I switch the letter of the function each time because after you create new ones, you can't keep calling it f of x. We already have an f of x. So you do have to switch the letters. They don't have to match mine. A translation 3 units down means it's happening on the outside, which means the sign goes with it, -3. So we get h of x equals x squared minus 3. A vertical scaling that's a vertical stretch means that when you multiply by the scale factor of 5, you should be doing so on the outside. So k of x equals 5x squared. Number 4, a translation left 4 units. Since it's left, I know it's going to go on the inside and be the opposite sign of what your gut tells you. So it's actually going to be plus 4 on the inside of the parentheses. So m of x equals x plus 4 in parentheses and then squared. For 5, you're doing a vertical scaling, so a vertical shrink with a scale factor of 1/3. Since it's vertical, I know I need to multiply on the outside, so it should be n of x equals 1/3 x squared. Now, when you're trying to write the formula from a graph, it can be very helpful to do what you see that I wrote next to it in green. You can always add the graph of the parent function, which when I'm looking at these graphs, they're all V-shaped, which means I know the parent function should be f of x equals the absolute value of x. So everything that I did to create these equations, we're keeping in mind that usually the graph of f of x equals the absolute value of x would be there, and it would have a turning point of 0, 0. So I used the critical point of 0, 0 to figure out what was going on for most of these. So in the one in the top left, using 0, 0 as my original parent function guide, I saw that it translated left 6 units. So that means I need to add 6 on the inside to get a of x equals the absolute value of x plus 6. When I look at the top right, I know that the absolute value function usually goes like this. So it's been flipped upside down, which means it's a reflection over the x-axis, as well as it's skinnier than it usually is. So I drew in blue f of x equals the negative absolute value of x, at least the reflection, so that I could show you the 2 coordinates. I used 1, 1 on negative absolute value of x, and I compared it to what the output would be on the actual graph we're trying to write the equation for, and I get a coordinate of 1, 2. So you can see that the outputs were multiplied by 2. That tells me I need to multiply by 2 on the outside. So b of x equals -2 times the absolute value of x. For the bottom 2, I again use the point 0, 0, that critical point from the parent function. So in the bottom left, I could tell that it translated 1.5 units right, which means it's c of x equals the absolute value of x minus 1.5. It's on the inside because it translated right, and notice against your gut feeling, it's not adding, it's subtracting. And then on the last picture on the bottom right, that critical point went up 4 points. So I can see that I translated up 4, which means I'm going to add 4 on the outside to get d of x equals the absolute value of x plus 4. So you have to keep in mind when you're doing this to keep looking at the pieces, making sure they're keeping that slope of 1 or -1, because if they're not, then you also have to look at something like the top right where you're going to have a scaling going on. And that concludes your lesson on 4 interesting transformations, day 4.